China has made it. It's quite a feat. China's artificial sun has broken a world record. It's been able to produce power by fusion for a full 7 minutes.
Imagine a future where we can harness the power of the sun to create endless energy on Earth. Well, China has taken a big step toward that future by launching its artificial sun, a groundbreaking technology that could change how we produce energy. But why did China create this? And what does it mean for the rest of the world? Let's explore this exciting development and consider the possible impacts, both positive and negative, of having two suns. For decades, humanity has dreamed of creating a clean, nearly limitless energy source, and China may be leading the charge toward that future. In a move that has shocked the world, China successfully launched its artificial sun into space. Yes, you heard that right, an artificial sun. But what exactly does that mean? China's artificial sun, officially called the Experimental Advanced Superconducting Tokamak East, is a nuclear fusion reactor designed to mimic the processes of our real sun. For years, scientists have aimed to harness nuclear fusion, the same process that powers stars, because it offers nearly limitless, clean energy. Unlike nuclear fission, which is used in today's nuclear power plants and creates dangerous radioactive waste, fusion combines hydrogen atoms to create helium, releasing a huge amount of energy. Recently, there have been rumors about China's artificial sun, with videos showing a bright yellow ball shining in the night sky as it rose into the clouds. This raises the question, could this be the start of a future filled with clean, endless energy? While more details are still coming out, the potential impact of this technology is enormous. To understand the importance of China's artificial sun, we need to know how nuclear fusion works and why it's a big deal. The sun creates energy by fusing hydrogen atoms into helium in its core, which happens under extremely high pressure and temperatures over 27 million degrees Fahrenheit. This fusion process releases a huge amount of energy that powers the sun and supports life on Earth. Replicating this process on Earth is very challenging. Fusion requires heating hydrogen plasma to temperatures even hotter than the sun's core, over 100 million degrees Celsius, to overcome the forces that push atoms apart. China's artificial sun uses a device called a tokamak, which is a donut-shaped reactor that creates and controls the superheated plasma needed for fusion. Inside this reactor, strong magnetic fields keep the plasma stable and prevent it from touching the reactor walls, which would cause it to lose energy. What makes fusion so appealing is that it produces very little harmful waste and uses hydrogen, one of the most common elements on Earth, as fuel. Just 1 liter of seawater can provide enough fusion fuel to generate energy equivalent to 300 liters of gasoline. This potential for clean, unlimited energy is why China is heavily investing in fusion technology. China's artificial sun, known as the Experimental Advanced Superconducting Tokamak East, has already set world records, showcasing the amazing potential of this technology. China is not the only country that has achieved high plasma temperatures. In 2020, South Korea's KS-STAR, Korea Superconducting Tokamak Advanced Research reactor, set a new record by maintaining a plasma temperature of over 100 million degrees Celsius for 20 seconds. The sun is a vital part of our existence on Earth, providing light, heat, and warmth for life and plant growth. It makes up about 99.8% of the solar system's mass and is the largest star. China has long wished for an artificial sun to harness nuclear-generated power. In a recent experiment, the East reactor heated plasma to temperatures 5 times hotter than the sun's core, reaching an incredible 158 million degrees Fahrenheit, and maintained this reaction for over 17 minutes. This achievement is not just a scientific milestone, it offers a glimpse into the future of energy production. While the sun's core burns at 27 million degrees Fahrenheit, China's East reactor needs to reach even higher temperatures due to the lower pressures on Earth. The reactor uses lasers and powerful magnets to create these extreme conditions, allowing hydrogen atoms to collide and fuse, which releases energy. The impact of this breakthrough is huge. If scientists can keep fusion reactions going for longer and produce more energy than they use, the dream of using fusion power for commercial energy could become real. China's success has already put it ahead of other countries in the race to master fusion technology, and this recent achievement suggests we are closer than ever to harnessing the power of the sun here on Earth. The world is currently facing two major challenges: the need for clean, renewable energy and the urgent fight against climate change. Traditional energy sources like coal, oil, and natural gas contribute significantly to global warming by releasing large amounts of carbon dioxide. While nuclear fission is a low-carbon option, it produces dangerous radioactive waste that can last for thousands of years. In contrast, nuclear fusion offers the promise of nearly limitless clean energy. It produces no carbon emissions, generates little to no long-lasting radioactive waste, and uses hydrogen, which can be easily obtained from seawater. If we can successfully develop commercial fusion power, we could greatly reduce our dependence on fossil fuels and help slow the harmful effects of climate change. The tokamak reactor, held by France's Tour Supra Tokamak, maintained similar temperatures for 390 seconds in 2003, making it the most extreme nuclear reactors to come close to China's Supertomatak. Scientists working on China's artificial sun project believe that the East is safe, as modern-day tokamaks typically contain less than 1/10 of 1 gram of hydrogen at any moment. If a disruption occurs during a reaction, the reaction immediately cools down and stops, making a nuclear explosion near impossible in a tokamak. Despite this, scientists are still going the extra mile to build additional safety measures into fusion power plant designs to ensure that even if a cataclysmic breach occurs in a tokamak, it would only create small radioactivity problems outside of the plant. The Sun, which is about 4.5 billion years old and one of the youngest stars in space, is estimated to keep burning for another 5 billion years. China's artificial sun could be crucial in making this future a reality. Its ability to maintain fusion reactions for longer periods brings us closer to building fusion power plants that could supply electricity to cities and industries worldwide. Unlike solar or wind energy, which rely on weather conditions, fusion power would provide a steady and reliable energy source, transforming the global energy landscape. Additionally, fusion power could lessen geopolitical tensions related to fossil fuel dependence. Countries that rely heavily on oil and gas would lose some of their influence, as fusion would offer an energy source that everyone can access. This could lead to a more stable and fair global energy market. China has made a major breakthrough with its artificial sun fusion reactor, but there are still significant challenges before fusion energy can be widely used. The key is achieving net energy gain, where the fusion process produces more energy than it consumes. While China's East reactor has made incredible progress, scientists are still working to make fusion practical and efficient for everyday use. China's artificial sun is more than just a scientific achievement. It's a beacon of hope for a future powered by clean, limitless energy. As the world faces increasing challenges related to energy demand and climate change, fusion could be the key to a sustainable future. The breakthroughs made by China with the East reactor show that we're closer than ever to harnessing the power of the sun here on Earth. Thank you for joining us on this incredible journey into the world of nuclear fusion and China's artificial sun. If you found this video fascinating, be sure to like, share, and subscribe for more deep dives into the latest scientific advancements and space exploration news.